would you like to look at? Anybody else but Royer? Anybody? What do you got? Do you have $1? Sweet. All right. Let's see, that was what? I might not have this. I closed out the PDF. Sorry, I closed out the PDF file. Why would I leave these open? You said 28, right? You know, I've had quite a few questions on 28. Yeah, I was actually one of those things that's sometimes you get the problems that you get questions on surprise me sometimes. Now, one of the things I want you guys to remember is that when you're working with these and you're trying to simplify out, figure out what your common denominators are, always go through and see what they have in common first. In an example like this, what do they have in common? They have 6's in common. So I know that I'm going to have a common denominator of a 6, and they both have a 6. And now you go through and figure out, well, what else is there? There's an x, and then there's the quantity x minus 2. Do you see that? So I write it as x, and then x minus 2. Don't treat that junk in parentheses as anything else different than just junk in parentheses. It goes through the same thing when you get into the other problems where you have parts of the denominator like 3x minus 4. It's not that you have a 3x and a 4 that you have to deal with. You have to deal with it in terms of an entire term. They just don't put parentheses around all of it at the same time. And now it's just a matter of going through what each fraction has versus what the other one has. Fraction on the left has the 6 times the x minus 2. What's it missing? It's missing the x. So I get a 7x minus. Now, the fraction on the right has the 6 times x, but it's missing the quantity x minus 2. So what I want to do here is, since I have to subtract out whatever it winds up being with all that stuff distributed together, I'm going to put a bracket around it because I know I'm going to have to distribute that negative later. So I'm going to have an x plus 3 times an x minus 2. So just above that right now, I'm going to FOIL out the x minus 3, x plus 3, x minus 2. I'm going to get, what's it, x squared plus 3x minus 2x, so I get plus x, and then I'm going to subtract 6. Reason I did it there instead of rewriting it, because it just, in this case, hi Shimki! Hey, little Shimki's here! The reason I want to do that is because now I can distribute it and leave it out of problems. I get 7x minus x squared minus x plus 6 all over that again. Combine your like terms in the numerator, you get let's see, a negative x squared. 7x minus x is a plus 6x plus 6, and it's all over the 6x x minus 2, and you're done. Now, when you look in the, if you got a chance to look at the solution manuals and stuff like that, a lot of times whenever they have a negative value in front of the first term, they generally factor that out. You don't have to. It doesn't bother me at all. That's fine. And you're done. Don't FOIL out denominators. Okay? Don't worry about it. Okay. 40? We good? Yes, did you forget to distribute it? Yeah, don't do that. When you get to 40, I'll get yours next, okay? Yeah, I don't have my passes out there like you're coughing, but you're gonna die. Real quick, so fake it really good, and then just get to drink water. Start faking so you can drink. Keep coughing. There you go. Do it. Keep going. I say that because it's missing, and I gotta get another one. So, kids are wandering the halls, cats and dogs. All right. obviously you might have noticed right away in that top fraction portion, you do wind up with, you can factor that denominator. You take out a 2, you get an x plus 1, x minus 1, because you might have noticed it had a difference of squares right there. I see that right off the bat because I would take out that 2 for the GCF and then work my way around. But I'm not going to worry too much about that yet because I have to deal with that awful looking denominator. So what I want to do is factor this. X squared minus 2x minus 3. When I factor that, what times what's negative 3, you add together to get negative 2, negative 3, and positive 1. So I'm going to have a 2 x plus 1 we have all of that. The denominator portion of the nasty looking fraction is the part that I have to actually do some work with. So I'm going to rewrite that top part. Then I get 1 over the 2 x plus 1 x minus 1. Here, my common denominator of all of this, well, what do they have in common with the x plus 1, x minus 3, x plus 1? What do they have in common? X plus 1. So they have the x plus 1s in common. What's left? The x minus 3. So now I go back to my fraction here and here. The fraction on the left has an x plus 1, but what's it missing? It's missing the x minus 3. So I'm going to have a 2 times the x minus 3. Fraction on the right has them both. So what do I write? Just x. So now all I have to worry about is simplifying the one numerator. So I have 2x minus 6 plus x, which is going to give me 3x minus 6 all over that. Which finally gets to the point where you've got fraction divided by a fraction. So I'm just going to take that top fraction and then multiply by the bottom fractions, reciprocal. Okay? So I'm just going to move this guy up here, flip it, and then 3x. Seems rather anticlimactic for all the work that we just did, because you only get to do one set of and then you're done. All you have to do now is write out the solution. X minus 3 over 2, x minus 1, 3x minus 6. Now, I could try and take out that 3 of the 3x minus 6 because it's another GCF. And I would get x minus 2. That would have been awesome if it was a 3x minus 9 because then I could have simplified out over the numerator. But you don't need to. There's nothing else you can do for that problem. Okay. It's just sad. No. Not too terrible.
Can we go over 32?
I will.
Okay.
Ms. Jordan? Fine. They want to help you anyway. I'm joking. I would help you. The joke. No. Hurts. You looked very sad a minute ago. You okay? I glanced over and I just want to make sure. Okay. All right. Pay no attention that I chopped it off at its knees, but you can kind of get the idea of what it was. This one is another one that you don't have to do any factoring on. You don't have to worry about any factoring for this problem, but, excuse me, what's your common denominator going to be? Put them together. Your common denominator here is going to be 3x plus 5 and an x plus 8. Okay? Fraction on the left needs a excuse me, an x plus 8. Fraction on the right needs the 3x plus 5. And now it's a matter of distributive property and combining like terms. When you do that, a lot of times people will do like what you did earlier, where how you forgot it was a subtraction, you wrote addition. It's one of those things you'll send the negative to the 3, but you'll accidentally make it a positive to the 5x, or excuse me, the 5. So we get 4x cubed plus 32x squared minus 30x minus 50 all over and it was nice that if you did distribute it out in the order in which it was written, it's kind of nice how it gave you it automatically in descending order and you have to really map it in. Better? What? What? In x? Well, because
How do you spell X?
well, and you know how it sounds? It sounds like an if you sounded it out phonetically, it's like an EX. So that's why they say an X. What's that? Ask me a question? Ask you? And egg? An E? Can I buy an E? I'd like to buy a Y. Or is it, you buy a Y in Wheel of Fortune? It's not an order. But sometimes Y. I'm just trying to stall to see how long I keep her arm up in the air. I think X, when you do that, it's if you look at it phonetically, it's E X, or it's E. Yeah, X. I don't know what I'm doing. I'd like an M.
Like an M.
Yeah, and it's the same idea because it sounds like an M. It's the first bond. It sounds like it's M. P. I'd like a P. Can I?
A P.
Right, and P, because I would like a P, please. You know, like if you had a bowl of peas and you just want to have a P, ask for a P. I would like an H, and H because it's an A. What's that? Because it's, when you say U, it sounds, if you spell it, it's like a Y. I don't know.
Well, like when you say when you say that way, you say then it turns into
I'd like to buy an U. This whole Wheel of Fortune way of figuring out letters is just messing with me. Anyway, we never get easily distracted here. Look, so this one is another one of those that you have 3 parts to it. But as you go through it, you'll notice that each one of them is not a monomial. Remember, monomial is anything that's just put together by multiplication, well, except for the x. But the first 2 terms are, x plus 1, 2x minus 3. I cannot separate any of those parts out of them to get commons. So my common denominator here is going to wind up being when I put all 3 of them together. And now I'm just going to get this really ugly looking fraction on the top. So the fraction on the left has the x plus 1. It's missing an x and the 2x minus 3. The fraction in the middle has the 2x minus 3. It's missing the x and the x plus 1. And then lastly, the fraction on the right has the x, but it's missing the x plus 1, 2x minus 3. And I'll tell you right now, that last fraction, when you distribute out, is usually the part that people will screw up because you've got a negative and you have to distribute through a FOILing process. Okay? I'm not going to rewrite my denominator, but I'm going to simplify this awesome-looking numerator. So I have 4x squared times that, so I'm going to have 8x cubed minus 12x squared. The next one is going to be plus 5x squared plus a 5x. This part is 2x squared minus 3x plus 2x is just a minus x, and that's a minus 3. So I'm going to get minus 8x squared plus 4x plus 12. Now, that's when you looked in the, this is the one that you looked in the solution manual that it said, I'm not going to do that. I'm not kidding. I didn't, the solution manual for this problem said, yeah, I'm done. I'm good. It didn't simplify it easy. They have all these fact checkers and thousands of dollars. I would ask that you would go and simplify the numerator again, put it in descending order. We get 8x cubed. Huh? You all right? Okay. Minus 12x minus 8x plus 5 is minus 15. X squared plus 9x line x, or line s. And you are done. And happy. It's ugly, it's kind of awful. It's so hard. Hold on to this for now. I'm going to add some more to it. I'm going to put a couple more of the complex styles on here in a second. So let me finish this one out, and I have got a really nice one I want you to try here in class. Really? Yeah, it's awesome. All right. Yeah. Yep. We're going to finish 9.5. That'll get us. I know I was going to ask before I go. So let's just say I wanted to ask you guys a random question about this problem. Random, because it just never would happen that I would ask something random that has something to do with math. Where are your vertical asymptotes for that? 0, right. There's one of them. -1, good. There's the other. All right. Where's your horizontal asymptote? No. All right. When we started this chapter, which seemed like a year ago, I knew it was getting violent. One of the things you might or may not have remembered is when we're dealing with the graphs of these rational expressions, a lot of times the graphs depended upon the degrees. Now, what's the degree of the numerator? 3, very good. What's the degree of the denominator going to be? 3. It's also going to be 3 because there are 3 x's. If you FOILed all that out, you wind up with an x cubed. Okay? Now, when you had same degree over the same degree, the rule was you would look at the leading term coefficients. That's how you would be able to figure out your horizontal asymptote. Now, in this case, you could what's your leading term coefficient of the numerator? 8. What's going to be the leading term coefficient of the denominator? 2. It has to be 2. Because if you just FOIL this part out, you get 2x squared, right? Put an x to it, and you get 2x cubed. What's 8 divided by 2? Where's your horizontal asymptote? 4. you have these little bits and pieces that you can be able to figure out without having to do anything, just by asking a couple of questions. Yes, sir. For the denominator, you can, but what I'm getting at is, if I just ask you where the asymptotes are, you don't need to, because your asymptotes get the zeros of the denominator. Since they're already in factored terms, you just get the zeros. Hold on, hold on. Yeah. Yeah. What's x? And also remember, if you have three x's in the denominator all being multiplied together, x times x times x is going to be x cubed, no matter what your coefficient is. Yes, ma'am. No. Where is it? Oh, there it is. I want to look at a problem. I want to look at a problem that kind of deals with kind of the worst case scenario of a simplification problem, where it's going to kind of mix together. Mix together kind of everything that we've looked at between adding, subtracting, multiplying, and dividing, as well as some of them we've got to remember about exponent rules. What's that? Oh, yeah. That's why we're doing this quick little reminder. So, real quick as you're getting to writing this out, what does x to the negative 1 stand for? X quotation device, yes. It's that's a good way of writing it. Yeah, that is x to the negative 1 is actually the quotation device. Good, I like that. You win. But if it did not have the quotation device, it would be. All right, enough of death and destruction and mayhem for the moment. X to the negative 1 is 1 over x. Now, what I want you to see here is that this problem then becomes he was right up next to the screen. I don't know what he's. All right, so do you guys all agree that there's, with this part here, there's really nothing I can do right now? So what I'm going to do is that I'm going to take this top part and rewrite it as its own complex fraction. This is a complex fraction over a complex fraction. Okay? Now, I'm not going to lie. This looks pretty ugly. Like, I'm sorry. I had to. It's been a while since I picked on you. I'm sorry. Now, do you guys agree at not only does this look awful, but there's probably just this portion for right now that we can probably do anything with? Because if I look at that, and I'm going to come back to this here, if I look at this, I have x over 1 over x plus 1 right now. That was that one portion of that awful looking mess of the problem. In this case here, this portion can easily be rewritten. What's the common denominator of an x and a 1? An x. The only thing they have in common is 1, but the common denominator between x and 1 would have to be x. Okay. Okay. When we go back here, if you go back, I'm just dealing with that portion first, because here I can simplify that down here. Fraction on the left has the x, fraction on the right does not, so that numerator in the denominator becomes. You okay with that? Thank you. Now, think about it again in terms of a complex fraction. Right. This is x divided by. Hey, can I write it as x plus 1? You guys be okay with that? Thanks. Instead of writing it as a vertical, awful-looking complex fraction, the moment you write it horizontally, it's less scary. Okay? It's kind of cuddly. Because, or not so cuddly, because then you can take the x over 1, multiply it by the reciprocal. And you get, nothing's crossing off, but what do you get when you multiply x times x? Squared. So this whole ugly thing that started out with the complex fraction wound up being something that wasn't too bad. If you think about it, that style is what we started the complex fractions with yesterday. But we just put them together into more complex parts, but we're chunky. So all of this equaled x squared over x plus 1. You okay with that? I'm going to rewrite the problem now. I have 1 over x minus x squared over x plus 1 all over 3x. Now, isn't that a lot nicer looking? What happens here, guys, is that you get complex fractions. And yeah, complex fractions are a bit of a pain. But sometimes you're going to get complex fractions within complex fractions. And that's where this stuff gets, that's about as crazy as this gets. Because now, it isn't so bad because you've got your, if I come back over here, what's the common denominator going to be between when you have an x and an x plus 1? X times the x plus 1. Remember, you treat that as a term because you can't split it apart because of the addition. Right? Never split anything apart over addition. Once again, fraction on the left has the x, it's missing the x plus 1. Fraction on the right has the x plus 1, it's missing the x. So we're going to have x cubed. Okay. I'm dividing by 3x, so when I rewrite that over here, I'm going to write that as times x over 3. And unfortunately, it's kind of anticlimactic again because you only get to do one set of. Oh, no. I gotta get the no-no-nos out of the way here because we only get to do this like one more time next semester. Oh yeah, I forgot to tell you. There's proofs second semester. I know. I always like ruining your afternoon. Are you frozen? So what I mean by what I'm talking about with proof, the proof stuff we do second semester deals with trigonometric identities. Um, it's what's going to happen is that we're going to have equations, solve for x, it's that whole thing again. We'll have equations that you'll have to simplify via properties to get a value of x that you can work with. It's not as awful as it sounds. It just sounds scary. If you remember that sine squared plus cosine squared equals 1, and sine is 1 over cosecant, or cosecant is 1 over sine, tangent minus 1 is secant squared, or cotangent minus 1 is cosecant. If you remember those, you didn't know either. It sounds awful. It's a lot easier. It's a puzzle. It sounds bad, but it's not. Don't worry, I rarely did either. And that's what you work out through. So what I'm having for you guys to do this evening, I posted it already on I think I posted it on the website. What I did was I took 10 problems. I took 10 problems off the worksheet, or a set of the old worksheets. I can rotate this. Where's the rotate button? Whatever. You'll figure it out. I hope so. Yeah, Chromebooks, you've got a button to do that. Anyway, I posted this online. There's 10 questions. There's 10 questions. There's two of the normal styles, and then there's 4 of the normals, and there's 6 of some of the complex. The complex ones don't get to that really awful style that I just did, but there are a couple of them. There's a couple of complex fractions in there to work yourselves through. It's posted through. Go ahead and start working on that now. If not, you can kind of tilt your head sideways on that and try to figure it out. Or actually, you know what? I know what I have. This is not ESPN. No. What's that? There's a button. It's like it's control above the form. There's a little arrow there. Or if you'd like, I have it on the smartboard normally. If you want to take a picture of it. Yeah, that's all. It shouldn't be that bad. I will suggest, as you guys are doing these, top tip here again, remember, whenever you're writing down the problems that are written in trinomial form or differences of squares, automatically write them down as factors. Factor them as you're going, and please, waste some paper. It's okay. Well, you can always, Arbor Day's coming up, you can plant another one. March? Like round. I don't know what to tell you. Concrete. I don't know where else you want to plant a tree. Mars. I don't know, the atmosphere is not all that great. So, what do you want? What? Uh, it wouldn't be a bad idea. Usually, those that do homework on a regular